Hello viewers, I am Maitli. Today we are going to see 12 Cbse Maths Relation and Function Exercise 1.3 question number 9. Let's see the question. Consider f the function r plus, that is the domain is real numbers, positive real numbers, to codomain here is minus 5 to infinity. Given by f of x is 9x square plus 6x minus 5, show that f is a invertible with f inverse y is equal to root of y plus 6 minus 1 by 3. We need to show the f inverse of y is this, and also we need to show that f is invertible. Invertible means it has both one-to-one and onto function. It is inverse. Now let us prove the one-to-one function. For one-to-one, let f of x1 is equal to f of x2. We know the f of x value. Instead of x, just write x1. 6x1 minus 5 is equal to 9x2 square plus 6x2 minus 5. Now this 2 get cancelled. Here we can take 3 common outside. 3x1 square plus x2 is equal to, here also 3 common, so 3x2 square plus x2. Now 3 gets cancelled. Sorry, 3. Now bring x1 to x2 square to one side. Now bring everything to one side. Now here it becomes 3x1 square. If I bring this to the side, it becomes minus 3x2 square. Here plus 2x2. Here if I bring this to the side, it becomes minus 2x2 is equal to 0. Taking common outside here, 3 outside, I get x1 square minus x2 square. Plus taking 2 outside, I get x2 minus x1. Now we know that this is in formula of a square minus b square. So I can write this to be x1 minus x2 into x1 plus x2. A plus b into a minus b formula plus 2 x2 minus x1. Now we know that these 2 are in common. So we can take common outside. If I take common outside, it becomes x1 minus x2 into 3x1 plus x2 here plus 2 is equal to 0. Now this we can write separately equal to 0, this separately equal to 0. If I write this separately equal to 0, it becomes x1 minus x2 is equal to 0. So x1 will be equal to x2. In this case, it becomes 3x1 plus 3x2 plus 2 is equal to 0. This cannot be equal to 0 because x belongs to the positive real numbers. If x is a positive real numbers, adding all the positive real numbers, it can't be equal to 0. So this is not possible. Adding the positive numbers 2 plus 3, it can't be equal to 0. So this is not possible. The equation itself is wrong. So we can leave this. We can write, if we prove x1 equal to x2, we can directly say that f is one-to-one function. So we have proved f to be one-to-one function. We need to go with the onto function. For onto function, let y is equal to f of x. If let y is equal to f of x, then y is equal to 9x square plus 6x minus 5. Bringing 5 to this side, it becomes equal to 9x square plus 6x. Here we need to write this to be x is equal to something means if there are two x square and a x term, we can't directly bring the x is equal to. For that reason, I am going to write this to be the whole square. For writing whole square, we are going to follow a method which we have done in 10th standard, that is completing square method. The method is dividing by, if there is something coefficient of x square, divide by it. So here it becomes x square plus 2 by 3x. Now when x there is a coefficient, divide by 2. We know that x coefficient is 2 by 3. So if I divide by 2, I'll get my b. I'm going to write this form as a plus b the whole square. Without changing the question, I need to write the form as a plus b the whole square. Here we have got a square plus 2ab. This is 2ab. In that, if you divide this number, the coefficient, by 2, you will get your b. So my b is 1 by 3. So 1 by 3 the whole square. 2ab plus b square. If I write something here, I need to write the same to this side also, because if this 2 get cancelled and there is no change in the question, I have not changed the question. Here let me solve this. This becomes y plus 5 plus 1 by 9. Here it becomes 3 square, so the denominator is same. So I can directly write it here. Here it becomes x plus 1 by 3 the whole square. Let me solve this and write it there in the next page. Here y plus 6 by 9 is equal to x plus 3 the x plus 1 by 3. X plus 1 by 3 the whole square. Now bringing square to this side, it comes as a root, so it becomes root y plus 6 by 3 is equal to x plus 1 by 3. Bringing 1 by 3 to this side, it becomes y plus root 6 by, y plus 6 root by 3 minus 1 by 3 equal to x. So x is equal to, as the denominator is same, by 3. Now you can't bring the number to inside the root, so I am writing it outside. So it is y plus 6 the whole root minus 1 by 3. This is your x value. The given is x belongs to r plus, that means x is greater than or equal to 0. X is a positive real numbers, means x will be greater than or equal to 0. We have found x. So substitute the value here. If I substitute the value here, it becomes root of y plus 6 minus 1 by 3 is greater than or equal to 0. Bringing 3 to this side, it comes and multiplies, so it becomes 0. So root of 6 minus 1 is greater than or equal to 0. Bringing 1 to this side, it comes as minus 1 will comes as plus 1. So root of y plus 6 is greater than or equal to 1. Bringing root to this side, it comes as a square, so it becomes 1 plus y plus 6 greater than or equal to 1. Bringing 6 to this side, it becomes y is greater than or equal to 1 minus 6, which is nothing but y is greater than or equal to minus 5. That means y is equal to, I am going to write an interval. It's a real number which is greater than or equal to minus 5, means my y will be including minus 5 till the infinite. So y is nothing but the range. We know that the range is equal to minus 5 to infinite, which is equal to the codomain what they have given. They have given codomain as minus 5 to infinite. So both are equal. If both are equal, we can directly say that therefore f is onto function. If the codomain and range is equal, we can say that the function is to be a onto function. And it's also f is bijective and invertible. If it is invertible, f inverse y is equal to x. We know the x value which we have found here. So write the x value here. So f inverse y is equal to root of y plus 6 minus 1 by 3, which we need to prove. We have proved it. That's all with the sum. Thank you.